Hey boys and girls, just going to quickly talk about variance. Variance is a measure of variability. Basically, that means the degree of spread in your data set. The more spread, the larger the variance is in relation to the mean. You should know what the mean is by now. Okay, we've got a couple of different things here. So this here, you've been used to seeing this symbol as the mean. That's actually the sample mean. This is our new mean for anything to do with population. Okay, so these two are the same thing, but one's for a sample, one is for a population. Now if we go have a look, sorry, some of my stuff has disappeared. There we go, the population variance we're going to look at first. So this xi, this means each individual value, and then we have our population mean as we saw above. If we square that, that indicates how far we deviate from the mean. Alright, this symbol here is standard deviation. You would have heard standard deviation before, but you probably don't know what it means exactly. So we're going to explain that in a sec. This symbol here you'll see as that is the population variance. Alright, so the population variance equals all of this. Now this might not make much sense just yet, but let's draw on this and make it simple. So we know this symbol is the sum, okay, of each individual value. So every individual value, take the population mean squared over the number of values. Okay, that's pretty simple. So this is n, the number of values. So it's the sum of each individual value, take the population mean squared over the number of values. The standard deviation is this. Okay, so the standard deviation is that, but it's square rooted. Alright, so anytime you need to work out the standard deviation of a population, we're using this. Now you've probably got some idea about how to then do the sample. So let's have a look at the sample variance. Now we're looking at sample mean. Okay, so this symbol here. Sample variance is indicated by S, by the way. Okay, so S is sample variance as opposed to this population variance here. Sample variance is equal to all of that. Again, that is literally just the sum of each of the individual values. So each of the individual values minus the sample mean now, squared, divided by, now this is where it's a little bit different, the number of values take 1. Okay, so it's the number of all the values take 1. And then of course the standard deviation sample is this, square rooted. Alright. Now where this comes into play is the standard deviations. If we have a normal distribution curve, this is a normal distribution curve. If you have not seen it, you will. We've got our mean in the middle. Okay, so our mean is in the middle here. Each standard deviation, so every standard deviation across, is indicated like this. So this is +1 standard deviation, +2 standard deviation, +3. This is -1, -2, -3, -4. And each of these standard deviations decreases or increases by a percentage. These percentages are indicated here. So one standard deviation across is 34% different to the mean. The next standard deviation is 13.5%. So each of those go up or down by each standard deviation. We'll go through this in class. Hopefully this will give you a head start.